In the next 5 minutes, an invisible race happening underground before every earthquake. A warning that can beat the shaking by a full minute. 300-year-old laws quietly running on the West Coast right now. And the exact signal your phone hears seconds before you ever feel a thing. This is the science of outrunning an earthquake. Segment 1. The setup. Somewhere in Mexico City, a siren went off 60 seconds before the ground moved. Not a guess, not a hunch. A warning, timed to the second, sent out while the earthquake was still traveling toward the city. No psychic, no crystal ball, just physics. The same physics that's been sitting quietly in Newton's notebooks for over 300 years. Segment 2. The Science Foundation. When a fault ruptures deep underground, it doesn't send out one shockwave. It sends out several, and they don't all travel at the same speed. That's the secret earthquake early warning system's exploit. First to arrive are P waves, primary waves. They race through rock at roughly 3.7 miles per second, compressing and stretching the ground like a slinky, and mostly they're harmless. You might feel a small jolt, nothing more. Behind them come the S waves, secondary waves, moving slower, around 2.5 miles per second, but shaking the ground side to side. These are the ones that crack foundations and topple shelves. That gap between the P wave's arrival and the S wave's arrival, that's the entire warning window. It's Newton's own laws doing the work. Every wave is just energy in motion, and every kind of motion obeys inertia, obeys force and mass, obeys the same 3 rules from 1687. A sensor picks up the harmless P wave first, calculates how big and how far the quake is, and races a warning to your phone. Faster than the S wave can travel there on its own. It's not prediction. It's a foot race between electricity and rock, and electricity almost always wins. Segment 3. The recent research anchor. In the United States, that foot race is run by ShakeAlert, the USGS system covering California, Oregon, and Washington. It now serves more than 50 million residents and visitors across the West Coast, and depending on how far you are from the epicenter, warning times can stretch from just a few seconds up to 50 to 80 seconds for people located far enough away. That gap matters more than it sounds. 10 seconds is enough to duck under a table. 30 seconds is enough for a surgeon to pause a procedure, a train to begin braking, a gas line to shut itself off automatically. Systems like this can trigger automated actions, slowing trains, shutting water valves, cutting power, before a human ever feels the shaking. The system isn't flawless. Warning times shrink dramatically for people close to the epicenter, sometimes to almost nothing, because the P wave and S wave simply don't have far enough to separate before both arrive. But engineers keep refining the network sensors and software to shave off every possible second. Because in this particular race, even 1 extra second can be the difference between a warning that saves a life and one that arrives just after the shaking already started. Segment 4. Closing summary teaser. So the ground never lies to us. It just talks in 2 different speeds. And for the first time in human history, we've learned to listen to the fast one before the slow one arrives. From nudging asteroids to outrunning earthquakes, it's the same handful of rules, running quietly under everything. Next episode, we're leaving the Earth behind again. For the reason a clock on a GPS satellite ticks faster than the one on your wrist, and why Einstein said gravity itself can bend time. I'm David. Thanks for listening. Stay curious.